Okay, in this video, I'm going to go over the PreQuiz 3.2, but I'm going to go over problems 4 and 5. Okay, so let's do that. This is an arc problem. These are a little more difficult, but not really all that hard. Okay, these are always going to be on a level field, which lets us make it actually pretty simple, right? So this thing is going to, if here's this level ground, right? It's going to go like that, right? Okay. It's actually going to be like a higher trajectory than that, but that's all the room I had, right? Okay, so what we're going to do is we're going to look at this launch velocity here, this initial one here. We launched it at, say, 57 degrees. This is 57 degrees, right? There's a horizontal velocity that it's got, and there's a vertical velocity that it's got, right? The vertical velocity is going to be, well, since that's opposite this angle here, we're going to use sine because we're doing SOHCAHTOA here, right? Okay, so the vertical velocity is going to be 27.4 sine 57, right? And then the horizontal is going to be 27.4 cos 57. Okay, so I'm just going to bust those out on the calculator here. 27.4 cos 57, 27.4 sine 57. Okay, so there they are, and we don't want to round too much. We've got 3 digits here. We probably want to carry 3 or 4. I don't know, I'm going to carry, they got 5 there. 4 is probably enough, right? So the x velocity is 14.92, right, meters per second, and the y velocity is 22.98 meters per second, like that, right? And then we're going to set up a horizontal vertical table like this, right? So we got horizontal, we got vertical, and we're going to set this guy up like this, right? And then these guys go in here. So this is my initial x velocity, 14.92, and then this guy, since this guy's of course 0, this guy's negative 9.8, this guy is 22.98, right? So this velocity here, this launch velocity here, goes in right there. Okay, and then there's other things we know. In the x direction, it's going to move some distance horizontally, right? In the y direction, though, it goes up, it comes down, it's going to end up at the same elevation. So that guy's 0. The other thing we know, and this is what I'll use, is that if it goes up at this velocity, it'll come down at the same speed, but in the other direction, right? What goes up comes down, and that's what we can do. That's because it's a level field. If it's not level, we can't do that, but we can do that in this case, right? And then my favorite thing is, of course, if we know that, is that we're going to find the time by using VF is VI plus AT, right? And so negative 22.98 equals 22.98 plus negative 9.8 times t. Now if you solve that on the calculator, right, you're going to go, I'm going to go negative 22.98, and then I'm going to subtract 22.98. Essentially, you got double negative that, right? And then divide by negative 9.8. I secretly, when I do this, I will just take that, double it, and divide by 9.8, right? But that's a secret between you and me. So when I do this, I get my time, and my time looks like it's rounding to 4.69, and that's because 22.98 is rounded, right? If I took my calculator and got the more accurate version, right? What is it here? 27.4 there, right? And go times 2 divided by 9.8. That's what I secretly do. And again, oh, that's a typo. The answer here should be 4.69. Okay, but anyway, okay, so now we've got the time here is 4.6897 is good enough, right? Okay, and then we're going to take the time, slide it across 4.6897, right? Okay, and now we can find, the final velocity here is the same as the initial And that's always true. It was true up there when we were doing the cliff problem. It's true here when we're doing this problem, right? And now we can find this x here because it's going to be velocity times time. This side is always just this x vt, right? And so if I want to find x, it's just velocity times time, right? So I'm going to go this guy times this guy. So that, what I have in my calculator right there is the time. And I'm going to go times 14.92, and I'll get 69.97, which is 70.0, is that right? 69.9, okay, good enough. Looks like it rounds up to me, but okay. Right, we can of course use the range equation to settle all disputes here, right? Let's just try that. 27.4 squared divided by 9.8 times sine of twice 57. Is that what it is? Wow, too many parentheses. 69.95, sure enough, it would round to 70.0, so that's also another typo there. Okay, so now let's just look at what we've got. Okay, let's answer these questions. So we filled those in, we solved it. Horizontal distance, I'm going to stick with 70.0 meters because I know that's right. Time in the air, we actually solved that first. It's going to be 4.69 seconds. Right? Speed at the highest point. Well, these are trick questions, right? So that's a trick question. Well, at the top, it's moving sideways, purely sideways. The sideways velocity is this velocity, and that's all it's got, 14.92. So that is my speed at the highest point. It's moving 14.92 over, and it's not moving up and it's not moving down because it's at the top, right? If it's moving up or down, it's not at the top, right? Okay, and then the greatest height that the ball reaches, we've got to do this whole thing here, this calculation again. So let's just set that up, right? X, VI, VF, A, and T. At the top, the final velocity is 0. Because if it's not 0, it's not at the top, is it? And then this guy's negative 9.8. This guy is our 22.98, right? And then I'm going to find x. I'm going to use VF squared equals VI squared plus 2AX, right? Okay. So 0 squared equals 22.98 squared plus 2 times negative 9.8 times x. And then, of course, when you put this on this side, it'll be negative. The negatives will go away. So you end up ultimately doing 22.98 squared divided by 2 times 9.8, right? So 22.98 squared divided by 2 divided by 9.8. And you get 26.9 meters. Okay. Now, on the skill set, on the skill set, these things, the way this is going to work is that there's really only 2 questions here, right? I think we're going to ask you this, and then we're going to ask you like a couple of these questions. There's 1, 2, 3, 4 questions. So that's, yeah, there we have it. Alrighty.